Okay, logical operators work as you would think logically, right? They perform element-wise operations. So they work exactly as you would think they do. So AND operations, uh, the double line doesn't work because yeah, it won't work. So just to show you why the double AND doesn't work, what does so checks. Yeah, it checks it compresses the values and checks it. So that's why it did work. Uh, or operations, etc., assignment operations are all in there. There's a bunch of other operators that you might find useful later on. There's in operations. In operations means you want to check whether a single value is within a big array or within a list. So that's when you'd use in. So is X in a list of variables? You'd do that. Similar to Python. Percentage char percentage is for matrix multiplication and not element, because if you don't do it this way, it's going to multiply them element by element. And if you put both of them within the percentage sign, it's going to do a full matrix multiplication. An example of how these work: if 2 is in V, then it's true, and if 32 is in V is false. It's very useful, not just like here. It's useful when you're running large loops. So if X is in this, then you keep doing this. While X is in scope, or while X is within a list, keep doing it until X is not within a list, etc., etc. So here's matrix multiplication. You multiply a matrix with its transverse. Yeah, T of M is transposing the matrix. So control flow is very similar to any other language. If then else loops are always there's no difference. There's a switch. Switch statement works exactly as you would expect. Repeat is do while, and while loops, for loops, etc., etc. You can break out, you can next. So again, these are very basic things that you probably already know, but put it in here just so that you have something to revise. Yeah. Okay, so this is how you would create a function. There's nothing too complicated about it. You create a function by giving a function name, putting in and assigning it to a function, and then putting in the arguments for that function. Right. It's very similar. And it's nothing too complicated about creating a function. But again, remember that if you're assigning a value, if you're assigning variables within that function, they don't exist outside the scope of that function unless you use if you use equal symbols, they don't exist outside the scope of that function. But if you use arrow symbols, then they will exist outside the scope of that function. So don't reuse variable names inside and outside of a function. That's going to mess you up. So yeah, this is how functions work. This is how you give pass in your own arguments. You can pass in arguments by uh, just by putting in the values, or you can assign yeah. And obviously, they assign they R has a lazy evaluation. So if there's nothing inside that function, it's not going to it's going to use whatever the previous function, whatever the value was supplied, and it's going to supply it to all the function arguments. So your libraries are going to be you're going to be using lots and lots of different R libraries. So just to be sure where your libraries are being stored, in case you need to clean house and you need to delete all the libraries and re-download them because you messed something up, libpaths is going to tell you where they are, and you can freely delete them later on. If you want to see what libraries are available, you can run the library function, or you can look at packages in RStudio, and it's also going to tell you what libraries are available for you to work with. Search function does search function stuff. ggplot2 is you have probably used, if you use Python, you've probably used ggplot. ggplot2 in R has the exact same internal structure because they are both written in Python, like they're both written in C. So the underlying structure for ggplot in both R and Python are the exact same. It can get somewhat confusing. So make sure that if you're using, I don't know, if you're using ChatGPT to generate your code, or Claude, or Google Gemini, or whatever LLM to use generate your code, uh, it can be helpful because ggplot commands can be fairly complicated, but they can also, you won't always know what errors you're getting if you're auto-generating code. So I always recommend, if you're using any of these LLMs to generate ggplot stuff, try to write it on your own, see what kind of errors you're getting, and then ask ChatGPT or whatever to solve it for you. And that contrast between how ChatGPT is going to do it and how you do it is going to help you learn how these ggplot functions work. Because a lot of times these auto-generated LLMs create very complex outputs and very complex results to create very simple stuff that you don't need. So again, try to write them on your own. Ask me, ask Janet, ask Arthur, and we'll help you out to format your ggplot commands for your graphs. Yeah. So yeah, I don't need to do that. Cancel. Uh, String manipulation is concatenation, works exactly how you expect. You can format, you can truncate, or you can expand values and variables. You can count the number of characters. You can convert strings to uppercase to lowercase. Uppercase and lowercase, just remember, it depends upon your locale. So if your computer has, I don't know, is in Chinese or Japanese or any of the other languages where upper and lower case does not correspond to English upper and lower case, is going to cause you problems. So if you're doing string manipulation, if you're calling these functions two upper and two lower, make sure that you have some command before running this to check what the locale of your program is. That goes for all kinds of string manipulation. If the strings that you're manipulating are in Arabic, or in Chinese, or hiragana, katakana, or any of those languages that are not in the original ASCII code, you might run into various different edge cases that are very difficult to debug. So make sure. It's one of those reasons, like I said earlier, you can name your variables like using emojis, but I recommend not doing that just for compatibility purposes. Substrings are substrings. There's nothing. Yeah. This is how you create vectors. You can create vectors by telling them how many variables you want as well. You can create sequences. So a sequence from 3 to 6, separating each value by 0.3. You see how that works as well there. And it's inclusive. So if you do 3 to 6, it includes both 3, and it includes both 6. Yeah. So another funny little thing, this is a soft failure, right? So I tried creating a vector with different data types. There was black, there was a color, there's 0, there's true. So there's logical, there's integers, and there's string. So what happens when you create a vector like that instead of a list is that it defaults to the broadest archetype. So because string like whatever the character archetype can contain all other things, that's what it defaulted to. If you had numeric and integer within a single list, it would default to numeric because numeric is a broader archetype than integer. So make sure when you have created a list, and if you have accidentally put in, say for example, you have created a list of like numbers, and inside one of those numbers was a character. Like instead of 0, someone had put in O, and you never noticed. And then when you have created the list, you'll find later on you'll find that the entire when you've created the vector, later on you'll find that the vector is not numbers, but it's character, and suddenly all of your calculation breaks. That happens a lot of like in real world data. That's going to happen all the time. So in places where there's, for example, you have numeric data, and the in some places you have someone didn't have data, so they put in dashes, or they put in NA, or they put in like a cross, or they put in nothing at all. So all these little edge cases, if you take a data frame, if they're in a CSV file and if they're in a data frame, and then you import it to your code, you'll find that like your vectors are not behaving as you expect them to, because they have defaulted to a different data type completely. So vector elements can be accessed by either name, by listing. So if you want, say for example, your vector has 10 million elements and you want element number 50 to 55, you can do vector then C50, 55, and it's going to uh, give you all those between 50 and 55. So there's various ways of indexing this. The logical indexing comes in handy. For example, if you have if you're indexing them by a comparison. So if you have a large vector and you're checking, okay, is if value in column 1 and is greater than value in column 2, I want to see what the value in column 3 is for that condition. So in these cases, this is going to come in handy. So you do column 1 is just create a new column for column 1 greater than column 2. You create, and then you mask the column 3 with the results of is column 1 greater than column 2, and then you're going to find all the values that fit that condition. So if you're accessing a large list based on some condition, this comes in handy. Again, you're probably going to need this for your first assignment itself. So we're almost done. At the end, I'll just give you a glimpse of the data set that you'll be using. So negative indexing means it's very similar to Python indexing, where it starts counting from the back. So if you do -1 to -3, it's going to start counting from the last element to the third last element. Similar to that, yeah. Element recycling is for example, uh, you repeat. If you want to create a large list full of repeating values, say for example, you want to fill up a list with a pattern, and this is what you'd end up doing. This is actually kind of useful if you're doing beginner coding challenges. So if you go to Leet Code and they ask you to do fizzbuzz or whatever, like there are some of the basic commands, and you for some reason you want to solve Leet Code using R, these little tips and tricks come in handy. Like these are small tricks that come in handy. So, for example, you see V1 is 6 elements long, and V2 here is 2 elements long. So what happens if you add them together? Well, R is not going to fail. Is what it's going to do in the back end is that it's going to stretch V2 to fit V1. So yeah, that's not always very intuitive. It feels like JavaScript in some ways, but yeah, that's pretty much how it works. V2, and then yeah, you see here V1 plus V2 has extended V2 to fit. So sorting is pretty good. It uses forgot what it uses a variation of selection sort, where it looks for groups of values. If you're sorting a very large list, you'll find that it's not very fast. So you probably have to import a library that does super fast sorting. But in general, it uses a variation of selection sort, as far as I remember. So data frames. We did data frames earlier, but okay, let's recreate the BMI thing again. And so str is structure. So it's going to tell you what the names of all of the columns are. It's going to tell you what the data type is and and I think minimum and maximum values within that. Sorry, it's just going to list all of the data. So str is very useful when you have imported a data frame and you want to see, uh, say for example, sometimes what really happens is that you import a CSV file and there are spaces in front of your column names. So if you want to see what's going on there, this is very helpful because it's going to show you there's a space in front of column. Telling you this because this happens to me a lot. People create CSV files, and in the first row of a CSV file are the column names. And sometimes people type in a column name, put a comma, put a space, and then types in different column names. And sometimes when you're importing those CSV files into your program, you'll find that that space has been imported as a column name, which creates a lot of problems because a lot of times you access values by typing name of data frame dot name of column name, and if there's a space, you can't do that. So you can directly get summary statistics. Uh, well, the very basic summary statistics you can directly get mean, median, mode, quartiles, maximums, and minimums. You can get all of that. And this is what I was talking about. You want to get the data from a data frame. You want to get the values of just one column because you want to perform some operation on it. You do BMI $, like data frame name $, column name, and it's going to give you that. You can create new data frames from old data frames. You'll be doing that all the time. You can create you can extract rows and columns in different ways. These are all examples. You can, if you're having trouble finding some way of accessing one particular column or a subset of one column. So that's why all of this is here, just so that it's useful for you. And you can add a new column to a data frame very easily. This is how you do it. You just get name of data frame, $, name of new column, arrow sign, all the values that you want to assign to it. It's as simple as possible. Now you have an ID column, etc. Now combining data frame uses rbind. So what rbind does is just let me show you. So rbind can it can combine them side by side, so by rows, or it can combine them vertically, so by columns. Sorry, I did that the other way around. This is by rows, this is by columns. So you can combine data frames in various different ways. So what happens is you take a data frame, you split it up into various values by you first factorize them, then you split it up, then you perform different operations on those different data frames, and you then combine them back together for whatever your final result is. You see, these are the two data frames, and then you bind them, and then you have this. This file system stuff is fairly useful. Oops, this is 2023. It's supposed to be whatever. So why this like getting working directory and setting your working directory to wherever you're writing your code is useful is because if you're we'll be giving you data sets, right? And that you'll be working on. So if your data set is in your download folder, then like reading that CSV file can get like complicated, right? And so you want to set your working directory to wherever your R files are right at that moment, so that when you're saving your plots, when you're saving your scripts, when you're loading in different CSV files, it's much more easier for you. So you can filter data sets directly. You can once you have created a data frame, you have modified all the data, you have added in all your information, and then you can just save it by simply write.csv. So this is very similar to Python. Read_CSV, here is read.csv, etc., etc. Installing packages. So for example, if instead of a CSV file, someone gave you an Excel file or a Google spreadsheet, I forgot whatever the Google spreadsheet tool is called, Google Sheets. So if someone has given you a Google Sheets file, there are libraries that help you import them directly. So the other thing is, yeah, you can import file like from one of these options as well. So you don't always have to install packages to do that, but this keeps everything in within code. So it doesn't have to be Excel or Sheets or whatever. It can be JSON, can be any of it can be cron jobs, it can be whatever you have. So there are thousands upon thousands of built-in data sets within R as well for you to play around with. These are mostly used. So, for example, you have a new command that you want to run, but you don't know what the results are supposed to be. So you import one of the built-in data sets and then you run your commands on top of it just to see what kind of results, what these results mean before running it on your actual data set. So empty cars is like it's a very old Motor Trend car road test. It's from the 1970s, yeah, 1974. It's a very standard data set, and any kind of manipulation you can think of has already been done on it. So yeah, so you can see miles per gallon, number of cylinders, etc., etc. So all of these are the structure and the column names of those things. Different types of plots. Okay, I'm gonna go quickly. Pie charts, bar plots, box plots. These are all things that you're going to be using. So make sure you know how to do this because again, these are part of your first all of you're going to be using all of these for your first assignment. So histograms, line graphs. So this is just a simple scatter plot, and this is scatter plot that's connected by a line. Mm, mm. What happened there? Okay, so yeah, these are plots. So one thing you'll be asked to do in your first assignment is a supervised scatter plot. Supervised scatter plot, what that means is that all these data points, they are either colored by a class or you're using, instead of circles, you're using circles and crosses or whatever. So for example, you're plotting two variables, right? Here you're plotting mileage versus weight. And there's a third variable, like some true or false variable. What a supervised scatter plot would do is it would just color this. So all the true values would be red, or in green, and all the false values would be in red. So that's what a supervised scatter plot means. So for problem set one, task one is this is the data set that you'll be using. Uh, this is Sean Lehman's complete baseball data bank from 1871 to 2023. And you will be, okay, let me show you what the data set looks like, just in case. So this is what the data set looks like. So you see that it's going to have years. A lot of these attributes are going to be dropped, so you don't have to worry about it. It's going to have ranks, games played, won, World Series win, etc., etc., and lots of statistics: runs, at bats, homes, two bases played, three bases played, home runs, shutouts, sacrifice flies, earned runs, complete games, etc., etc. Home runs allowed, bases allowed, errors, fielding percentage, etc., etc. So lots of very in-depth baseball statistics. So that's why if you're creating teams, make sure at least one person in your team has heard of the game of baseball. It's going to be handy. And what you'll be doing is, say for look, let's look at where is the what happened to the scroll bar? Okay. So you see that a lot of this data does not exist for a bunch of these. Hmm, so so you see this data does not exist like uh, so you see in the 1870s there was no World Series. The World Series started in 1903, 1905, something like that. So there's no World Series data at all. And you see that the sacrifice fly was not the statistic was not counted during the 1870s. So how do you deal with that? Do you ignore sacrifice flies completely? So let me have you. Please, top row. Okay, that's easy. So how do you deal with this, right? So this is something you'll have to figure out. So let's move to 2022. So again, uh, a lot of these statistics say, for example, you want to compare you're comparing number of home runs, right? And you want to see whether World Series winning teams have like obviously they score more home runs than the other teams, but by how much? How much has the statistics changed? All of that things. Are people in the like in the 1920s where they're scoring the same number of home runs as people in the 2020s? So all these to how do you check for that? How do you figure that out? So you have to do it. You have to calculate these statistics per game because these are you see that these statistics are per season, and you have a variable here called game. So a lot of times what you have to do is you count the number of home runs and uh, you divide them by the number of games just to get a more accurate statistic of how many home runs per game you're getting. So otherwise, if you compare data from now when there's 160 games versus in 1871 when there were only 30 games, a lot of those statistics won't really make any sense to you. So again, these are little things that you're going to have to think about, and uh, a lot of the stuff that I showed you today, a lot of the little tips and tricks that I showed you is going to be useful when you're dealing with this. And a lot look at the ranks now. There are multiple. There's what the National League and the what's that the league called? American League. Yeah, sorry. So if you want to compare the performance of teams and then you want to and you'll see that every season there are two teams at number one. So how do you compare that? So you can only compare teams that are within that particular league. Again, you have to factorize and then check for teams within that league. So again, this is one of those locations where factor is going to come in handy. What happens if a team changes leagues? If you look at the Houston Astros and the league that they're in right now, they were not in that league earlier, right? So again, if you take one team and then you compare their results all over from like 50 years ago, your results are going to be wrong. So these are like little edge cases and little scenarios that you have to deal with in real data. So again, you have to we'll tell you like what all transformations and what all you have to do on this data, but you have to figure out what all these edge cases are and what they mean and how to deal with this. So you can, if you want, you can completely drop one of the columns, like the sacrifice fly column, for example, or earned runs if you think that it doesn't really tell you anything. So again, this is a real world data set. You'll be doing lots of different like exploratory data analysis on top of it. And if you're having troubles understanding some of these, ask one of us and make sure you form your teams right now, like by Friday, because otherwise we're going to assign you randomly to teams, and you don't want to start working on a project like this with people you have never worked with before, or you have no idea who they are, and they may not be coming to class or whatever. So, and yeah, that's pretty much it for today. So, what's up? No, no, no. No, most of this, like I'll say like 90% of the assignments that we're going to give you, they're going to be interpretations, right? So there's not going to be any one correct answer for any of them. So your best interpretation is what we want. And the other thing is if you're using ChatGPT or whatever, like we don't mind, but please make sure that you mention it. That I have used Google Gemini, I've used Claude, or I've used ChatGPT for this assignment. And if possible, mention what you have used it for. Like what did you use ChatGPT in this assignment to do? Because that helps us as well. Like it helps us understand which part of this assignment is difficult so that you're using ChatGPT for it. Yes. Yeah, that's fine. Yeah, just mention that you're using an LLM. All right. If you have no other questions, then we are done. And